Okay, so once again, good afternoon, everyone. And we are going to continue our discussion pertaining to the Z test. So I believe that we already discussed the preliminaries pertaining to the Z test because we have already discussed it one last week. Now let's have to apply the Z test in a real world problem, especially in a research. By the way, can you hear my voice? Am I clear?
Yes, sir.
Okay, so here we have the problem. So we have after implementing a new GPS based dispatch system in City A, the Emergency Management Office wants to know if response times have changed compared to the City B, which still uses the traditional dispatch systems. So they collected the response time in minutes for medical emergencies during the same month. So you have the City A and City B. Now, if you can still remember, we have the process on how to solve the what we call this one, the Z test. Okay, so now from the discussion that we had previously, okay, our for our solution, okay, our step one is to identify the hypothesis, both null hypothesis and the alternative hypothesis. Now, how to identify the hypothesis? We are going to base our discussion to the what is in the problem. So for in this case, as we can see here, we have here if the response time, okay, so here if the response times have changed, so meaning, okay, we can interpret this phrase if the response times have changed, we can interpret this one or translate this one into a mathematical statement. Since according to this phrase, response times have changed, it means to say that it's not equal. Okay. So in other words, according to this one, if the response times have changed, meaning the e- relation symbol becomes not equal. Now, if our CTA is our x sub 1 and our CTB would be x sub 2, it implies that CTA would be mu 1 and CTB would be mu 2. So here in the statement, the emergency management wants to know if the CTA, okay, the response time in CTA have changed compared to CTB. So meaning you have mu 1 is not equal to mu 2. Okay, since you have hypothesis of not equal, meaning this would be our alternative hypothesis. And our null hypothesis would be mu 1 is equal to mu 2. Again, just for emphasis, we can formulate or we can identify our hypothesis based on the given. So for the given, in the statement, if the response times have changed, meaning the response time of CTA is not equal to the response of CTB. Okay, as we can see here, our alternative hypothesis would be the claim of the researcher. Okay, so take note, our alternative hypothesis is the claim of the researcher. So we have already identified the step 1. Step 2 is we need to identify the critical value. Okay, now from this would be our convention. If in the statement, if in the problem, the alpha level is not identified, then our automatic alpha level would be 0.05. Otherwise, if what is stated in the problem, that would be the alpha level that we are going to follow. Okay, so from the statement, there is no alpha level, meaning that our alpha level would be 0.05. Now, for us to identify the critical value, we need first to identify whether the given problem is a two-tailed test, a left-tailed test, or a right-tailed test. So for this case, based on our alternative hypothesis in which the mu1 is not equal to mu2, this is two-tailed test. Okay, since this is two-tailed test, okay, since this is a two-tailed test, we can now identify our critical value based from the presentation that I gave you last week. Now, okay, so since our alpha level 0.05 and it's two-tailed test, we have a critical value of positive negative 1.96. So if we are going to illustrate this one, the critical value of negative positive 1.96, this would be the illustration. If you have your normal curve, okay, so taken that this would be our 0. So it means to say that the negative 1.96 would be this boundary or this line. So you have negative 1.96. And for the positive, so you have this one. So this would be 1.96. It means to say that if our computed test value falls within the shaded portion, it means to say that our null hypothesis would be rejected. The same on this side. Again, if the computed t value or the computed value rather would fall under this shade, then our null hypothesis would be rejected. Okay, now we already uh, identify our critical value. By the way, if the computed test value will fall within this unshaded portion, then we could now say that our null hypothesis would be not or fail to reject. Okay, so for in this case, we can now have our third step. For the third step, we're going to compute the test value. Okay, for the test value, we're going to use the z-test. Okay, so the formula for the z-test would be you have now for this symbol, this means to say that this is the sample mean 1. Meaning, for this example, the mean of the CTA minus the sample mean 2. Meaning, we are going to get the mean of the CTB minus the population mean 1 minus population mean 2 all over the square root of the population variance 1 over the sample size 1 plus the variance 2 over the sample size 2. Okay. Now, for in this case, we are going now to identify the values. So you have now mu1 minus mu2. So So where are we going to get the value of mu1 minus mu2? We go back to this null hypothesis. As you can see here, mu1 is equal to mu2. If we are going to subtract both sides by mu2, it means to say that you have mu1 minus mu2. So mu2 minus mu2 equals 0. So in other words, mu1 minus mu2 is equal to 0. Next, what we're going to look for is the sample mean of the CTA. Now, what you're going to do here is we're going to use the calculator. Now, previously, I asked you that your calculator should be with you when we are going to discuss the topic. So I am assuming that you have your calculator now. Okay, so taken that this would be the features or the interface of your calculator. So what you are going to do is you have to click the mode and then look for stat. So in this case, the stat is 3. So you are going to type 3. Now, uh, you have here some options, 1 var, a plus bx, and so on. So we are going to choose 1 var. Now, if your calculator is not the same with the interface of the calculator that I have here in the screen, what you're going to do is you have mode and then look for SD. Again, mode SD. And then what you're going to do is you are going to type the numbers. So for example, if you have 8.2, you type 8.2 then M plus. Again, if your calculator would be having the same interface as my calculator in my screen, what you are going to do is just you are going to type the number. So you have 8.2 then equal sign. Okay, next 7.5 equal sign. Then 9.1 equal sign. 6.8 equal sign. 8.4 equal sign. 7.9 equal sign. 8.6 equal sign. 9.3 equal sign. 7.1 equal sign. 8.8 equal sign. 7.4 equal sign. 8.9 equal sign. 6.5 equal sign. 8.1 equals 7.7 equals 9.4 equals 8.3 equals 7.2 equals 8.7 equals 6.9 equals 8.5 equals 7.8 equals 9.2 equals 7.3 equals 8 equals 7.6 equals 8.8 equals 6.7 equals 9 equals 7.5 equals 8.4 equals 7.9 equals 8.2 equals 7 equals and 8.6. So as you can see, you have 35 numbers, meaning that our n sub 1, wait for a while, okay, meaning that our n sub 1 is equal to 35. Okay, now next step, yeah. So what
Okay,
we're
sir.
going to do here is, after this one, is you click AC. Okay, now in this case, uh, for this calculator, you're going to have shift tapos 1 and then type 4 because that's var. And then you are going to select the mean. So that's 2. Then equal sign. So for this case, we are going to have the 5 digits. Okay, round off 5 digits. So you have 8.03714. Okay, for those calculators, you have different interface with the calculators that I have in my screen. What you're going to do is you have to shift, then in the keypad, the number keypad, look for var there. Usually that is on number 2. So shift 2 and then look for this symbol. Look for this symbol. And then type that number where this symbol is associated and then equal sign. Then you have your 8 point. So, and then, so we have now our value of our mean for CTA. Okay. Now, next, we are going to look for the value of our variance. Okay. So, what you're going to do, you press AC, then the same, shift 1 for stat, then 4 for variable rather, and then look for this symbol. Okay. So 3. Now, this is standard deviation. But what we are going to look for is the variance. So next is you click the x squared and then equals. So still, we're going to look for 5 digits. So you have 0.628 62862. Okay. Now, this is just for the CTA. We haven't yet computed the CTB. So what we're going to do is we are going to follow the same order. Okay. Now, however, we are going to be sure that our data must be 0. So to clear the data, you click shift and then look for CLR. Okay, in your calculator. So for this case, the CLR or the clear is in 9. So press 9 and then press 3 and equal sign. Then AC. So same process, mode, stat, 1 var. And then type the uh, the data for CTB. So you have 10.5, 9.8, 11.2, 9.3, 10.8, 11.5, 10.1, 9.7, 10.9, 11.3, 9.5, 10.6, 11, 10.2, 9.9, 11.4, 10.7, 9.6, 10.3, 11.1, 10.4, 9.8, 11.2, 10, 10.8, 11.6, 9.4, 10.5, 10.9, 10.9, 11, 10.2, 11.3, 9.7, 10.6, 11.1, 10.3, 9.9, 10.7, 11.4, 10.1. So that is 40. So again, our n sub 2 is equal to 40. So for this case, we can now have our sample mean 2. So for the sample mean 2, we just press AC, shift 1, 4, and then 2. So we have now our mean of 12.87 exactly. Okay, next you're going to have the variance. of CTB. So what you're going to do is, again, AC, shift 1, 4, and then 3. Then shift the x squared for you to get the variance. So the variance is 218.0441. So let me check first the data. Baka ako yung mali. So the correct mean must be 10 point. So let me check. And for sure, this is wrong. So this indicates that we have to double check our data. And then how about the the variance? So that is 0.40469. Okay. So we have now our values. We have now the values of every uh, variables in the formula. So what we're going to do is we have to substitute. So you have our x sub 1, the mean sub 1, sample mean sub 1 is 8.03714 minus 10.5075 minus 0 over the square root of, you have 0.62862 over 35 plus, you have plus 0.40469 over 40. Okay, so we can now have our, what do you call this one? We can use our calculator. So you have 8.03714 minus 10.5075. So that becomes negative 2.47036 over, okay, square root. So you have 0. Oh, wrong. Okay. So you have 0.62862 divided by 35. So the answer is, in this case, let's have round off 5 decimal places. Okay, to be sure. Okay, so you have 0.01796 plus, okay, so you have, next is 0.40469 divided by 40. So the answer is 0.0101242. Okay? So you have 0. Oh shoots. So you have 0.01796 plus 0.01469 1012. Okay, so in that case, you have negative 2.47036 divided by the square root of 0.02808. Okay, so next you have square root of 0.02808. So you have negative 2.47036 over 0.16757. Okay, so you have negative, oops, negative 2.47036 divided by 0.16757. So here in this case we have a round of three decimal places. So negative 14.742. Okay. So in this case, we have now our computed computed value. So take note that for our number 4, we are going to have the decision. So for the decision, okay, we're going to follow the rule. Since this is what we call this one, two-tailed test, if the computed test value, the absolute value, okay, is okay, so here our computed test value is the absolute value of negative 14.742. Okay, how about the critical value? That is 1.96. Okay, absolute value. In this case, is the computed test value is less than or greater than 1.96?
Less than, sir.
This is, take note that we are taking the absolute value. So this is, what is the absolute value of negative 14.742? So this is positive. So that becomes greater than. And since it's greater than, the null hypothesis is failed to reject. Okay? So since it's failed to reject, we can now say for our conclusion, we have to reject the claim. Therefore, so if we go back to our claim, remember that the claim here is the alternative. Okay. So, okay. So we fail to reject the null hypothesis, meaning we reject the alternative. So there is now, according to the problem, if the response have changed, meaning, okay, it means to say, it implies, okay, therefore the response time have changed, have changed. So it implies that after the use of the GPS, the response time is or changed. So as we can see, the CTA, okay, the CTA is lesser than the CTB. Meaning, okay, this implies that the CTA has more effective response compared to CTB. Furthermore, the GPS system is effective. So that's how we are going to use our z-test.